Hello, everyone, and welcome to the December Recreational Astronomy Night Meeting, online edition of the Royal Astronomical Society of Canada, Toronto. My name is Paul Markov, and aside from introducing the speakers, I also search for presentations for upcoming meetings. So if you have a presentation in mind, please get in touch with me. We have February and later meetings. Before we start with the presentation, I would like to thank our technical team comprised of Andrew and Betty Reed, Blake Nancaro, Lucci. Thank you guys for making these online meetings possible for us. Speakers lined up for you tonight as usual. The first is Ron Macnaughton. He will be delivering the sky this month or this evening. A special guest speaker, we have Dave Lane, RSC president, joining us from Halifax, and he'll talk to us about the Mini-Robotic Observatory. Jerry Vila is our and the life and discoveries of Galileo Galilei. Tom Luton, our new life will close the meeting with announcements. If you have questions for our speakers, please enter them in the YouTube chat box, and Blake will ask the questions on your behalf at the end of each presentation. If you are attending a Toronto Centre meeting for the time, please let us know through the chat messaging as well. So let's get the presentation started with Ron Macnaughton and the sky this month.
Thank you, Paul. The plan of the talk is different than I usually do. I'm going from near, i.e. things on the Earth, to far, deep sky. I'm fascinated by Anolemnos. We take a photo at the same clock time throughout the day, not changing for daylight. And often you do it on regular intervals, and this is every fortnight by a group at the Bell Labs in New Jersey in the afternoon. If you take it exactly on the local mean noon, and I'll explain that a little later, and the yellow line is my guess at due south, and every astronomical rises in the sky, it's highest when it's due south, and then it comes back down again. But the sun is not always crossing at the mean noon. In November, because it's going much faster around perihelion on January 2nd, in November, it ends up that we're a significant time before noon, and it doesn't even get to noon before mean noon, and it takes another few minutes, 15 minutes to hour. This is part of the RASC handbook, and they've just stretched the time axis, and I've marked January 9th. Now, I'm going to explain what the time of noon is by talking about, for the Ontario Science Centre, where we usually meet, latitude 3 degrees west. And the local noon is 12 o'clock because of standard time. And you subtract 79.3 center of our time zone is latitude or longitude 75, and divide it by 15, and it ends up being about 17 minutes. So our local mean 12:17. But it turns out on December 9th, where somewhere around 7 minutes, the sun is fast. So like 7 minutes away from that, and the local noon, when the sun is high, is 12:10 p.m., and it's very close to the actual value that Starry Night predicts. Anolemnos are on globes, old globes, and it goes from the Tropic of Cancer to the Tropic of Capricorn, and they have every 5 days is marked around the year, and you can work out the how many degrees from the celestial equator the sun is at any given day, and the relative position of whether the sun has noon early or late compared to the mean. Okay, believe it or not, this is the date with the earliest sunset for the year. You'd think it would be December 21st, but it's a little complicated how everything works. And 4:40, the sun sets tonight, or has set actually. And we have different times for civil dusk when it's 6 degrees down, nautical dust, and astronomical dust and dusk. And we have 11 and a half hours of astronomical dark conditions for photography. And if you want to use all 11 and a half hours, I suggest you might have to visit 2 Tim Hortons, because I doubt if one of them has enough coffee for you. This month in history. I just added this. The sample from asteroid Ryugu landed in Australia, and the Japanese project, this man is carrying it back, and they'll do all sorts of analysis. GoldenEye, the Bond movie, the galactic battle was at the Arecibo telescope. And sadly, one of the cables broke and damaged, and I doubt if they're going to rebuild it, which is too bad. If you Google online, there are amazing videos taken by a drone moment that it broke. But I'm in my talk. The next December event is the first moon was in December, and these 3 astronauts, 10 orbits around the moon, took a picture that many people thought everybody would realize we're on one planet and we should get along. And they were selected as Men of the Year by Time Magazine. So much bad news otherwise in 1968, almost as bad as 2020. Interesting, the Neil and Buzz, who actually landed on the moon, never made that honor, and this has got to be the ugliest cover I've ever seen. But the last trip also in December 72, and they did 36 kilometers of roving, took 66 kilometers of rocks back, and this is Eugene Cernan in Sudbury, and he took this picture, my favorite from the moon, of Harrison Schmitt, the geologist, exploring this rock. And to me, that encapsulates the grandeur and moon. And when he came to the movie Last Man for the Moon, he autographed it for me. My last event is Isaac Newton was born on Christmas Day. And I don't know if Roy Bishop is online. I emailed him and asked if I could use this picture that he took of Newton's childhood home. And when he and his wife were there, it was closed, but the caretaker gave him a brief tour. He wanted a picture in the sun, so town, and then saw an opening in the clouds, and they started to walk back, and then rain started, and as a physics teacher, he thought, rainbow? And he went to a place he thought would be perfect for the rainbow. He put a new roll from 64 in the camera. His wife held the umbrella. This is the best rainbow picture I've ever seen. And now, what's special about this? Newton research about light, and he would show that a prism would break white light into colors, but he also showed you could recombine them in white. And this was disputed by some people who didn't have as good prisms, but it's obviously correct. And he also thought anytime you have a refracting telescope, you're going to get separation of colors. So maybe we should have a different design of telescope, and it's called Newtonians because of that. But I thought the apple story was apocryphal. But he actually told a number of people he was at his childhood home to social distance during a plague, and told several people who recorded it at that time that he actually saw an apple tree and saw the apple falling straight down. He wondered, why is it straight down? And then he thought, well, if the earth, when I'm sitting on a bench, like it pulls an apple, but maybe it also goes all the way to the moon, that causes the moon to go into an orbit. And he basically laid the foundation of Newtonian physics until Einstein changed things. And Professor Bishop, thank you very much for your email if you're listening. And he ended his email by saying Newton showed that nature's laws are the same in the heavens and on Earth. Christmas Day. Rocket launches. I'm going to point out 3. A Long March rocket is going to launch a pair of satellites to detect gravitational waves. I'm not quite sure how it works. An Electron rocket from New Zealand is launching Strix A, and it's a radar for urban planning accurate to millimeters, believe it or not. And some date in January, a Boeing Starliner is going to be launched for an orbital test, and eventually, if it gets approved, it will carry people to the ISS. August 13th was a magical night for me because I left my cottage lights on and I took a boat to the other side of the lake with a view of where the Perseids come from. And I just had my camera running on automatic repeat every 30 seconds. And I sat in a lounge chair and it was just so wonderful. In a meteor shower, they all seem to come from the same area. And this is the Perseids all come from roughly this area in the sky. And on the 13th, we have a major shower of the year, the Geminids. Now, the peak in terms of the number of particles approaching the Earth per minute or whatever is highest at 1 a.m. Universal Time or 8 p.m. on the 13th for us. And in theory, the zenith hourly rate is 140. Sources say 150 or 120. I don't know. So it's right next to Castor. I've 3-degree circle in blue, and meteors are going to be going all over the sky and even more than the Perseids. But this is a view above the Earth, and the sun is shining from the left. So this is the day side. This is the night side. And in the early evening, we're here, and some meteors go over the North Pole, which of course is tilted away from the sun. That's what the red's supposed to be. But if you wait till at 12:10, the opposite to the noon, it's going to be opposite the sun, and about 2:30, Gemini is going to be the sky, and you're going to get pretty close if you're in a really dark site to the zenith hourly rate. And if it's clear, I'm driving somewhere and I'm going to let my camera click away and I'm going to sit in my car and just soak up. And if it's really warm, I'll sit outside, but I doubt if it's going to be like that. Here's a diagram from 1872 of the Perseids. And even then they knew there was some into the streams. We get a Swift-Tuttle was discovered before then, but I don't know whether it was related to this shower. And the peak then was the 10th, and now it's the 12th. Now, the source of the Geminids is Phaethon, and it has a short period, 1.4 years, and it goes really close to the sun. This is the orbit of Mercury. And it's an asteroid. It doesn't have any dust coming off it, but the theory is it used to be a comet, and everything got burned off it, and it's creating the stream that we see. Swift-Tuttle, in contrast, is much further out. This is a Uranus orbit, so it's way out, and it also goes opposite the direction of the planetary rotation and not the others. Now, I picked out 4 from the Wikipedia list. And it's interesting that the speed of the Geminids is slower than the other big meteor showers. And that's it comes something close. Now we have one more meteor shower just a little bit into January of the Quantrids, and they identified Quadrans as a constellation. And then when some committee of scientists or astronomers got together, they decided to remove it. This is going to be a stunning event. There's some ISS passes right now, but later on in the month, they're going to be more Christmas. The moon. There are 3 things that define the moon, and the most important, I guess, is the phase, and 14th, it's new. And when Santa visits, it's going to be between first quarter and full moon, so the waxing gibbous moon might give enough light that he doesn't need Rudolph, or maybe he will. But there are 2 other things, and one is the path compared to the ecliptic. Sometimes the moon is above the Earth-Sun plane, and sometimes below, and it turns out it moves south on the 14th, which is also the new moon. And when that happens, you get an eclipse. And this will probably be the eclipse in a developed country that has the fewest visitors, because I know several people who were going to go to insurance, and so it could be hardly anybody will see it. Third thing, distance to the Earth, and sometimes the moon is closer and sometimes further away. My diagram is grossly exaggerated. Further away, the moon is smaller in the sky. And if that moment is when you have a solar eclipse, it doesn't cover the whole sun, so you have an annular eclipse. And if it's closer to the Earth at either full or new, you have a supermoon if it's full, and you have a moon that covers the sun and gives a long, juicy eclipse. Now he gets to the solar system. This diagram is not to scale. The planets are something like than distances shown by the orbits with there, but it gives an idea of things. On the evening side, we see things behind us in orbit. So we passed Mars in October, and we can see Mars all evening in the sky, and it's actually still pretty good for looking at. Sirius is also good to see. Now, in the morning, we see objects ahead of us, and Venus passed us in June, so we can see Venus, although it's getting closer to the sun and eventually will pass on the opposite side of the sun. But the star of the show is the two gas giants, and they're going to get very close to each other on the 21st. And I'm first going to show sky view as we will see it, and then I'm going to use this program to show what it looks like from above. So tonight, 5:30, they were something like less than a degree apart, but 4 days later, they're A, lower in the sky, and B, closer together. Another 4 days later, they're closer. Now the moon's passing because remember it was new on the 14th, so it's a crescent. And on the 21st, it's even lower still, and they're going to be very close together. So let's look at what above. Here's the line. Remember, the planets are something like 1,000 times smaller than the diagrams here. And as we move forward, Earth is moving counterclockwise and Jupiter's catching up to Saturn. But on the 21st, they're more or less in a straight line, although there's a slight tilt between each, and I'm going to explore that. So when are we going to be able to see those two planets? So on December 2nd, it was nice and clear at sunset. So I drove a place near Bolton with a good view, and I could see Jupiter 17 minutes after sunset. 19 minutes before the Saturn, and it's much fainter and it's a surface brightness because it's further away. So basically, we can see both at that day, 36 minutes after. On the 21st, the two planets are going to be Capricorn, Capricornus opposite from Aquarius. The bearing is going to be 224 degrees. It's almost exactly southwest. That is 4:44. 36 minutes is 5:20. Because it's lower, I think it's going to be a little after that, and my analysis is for 5:30. And what we're going to be able to see is in the one eyepiece, we're going to be able to see Jupiter, Galilean moons, and Saturn plus a number of moons, but the sky never gets completely black, so we're only going to see a few of them. And next to each other in the same eyepiece, and am I ever looking forward to that? How far apart are they? It's about 6 arc minutes. At 1 o'clock in the afternoon, they were actually closest, and people in Egypt got a good view of them, and they're a little bit past the closest approach. So can we see that? Well, here's an eye chart, and I consulted with Ralph Chu about this. The 2020 line, the letters are 5 arc minutes tall. And line, each prong would be about 1 arc minute. And as long as they're bright enough, I think I would see 2 dots that are that close together. And people have seen other planetary conjunctions, and it's been like that. But we'll see. So where to see it? Some people talked about the shoreline, but this is the actual bearing of the event. And for most of the shoreline, we can't get a view. Maybe East Toronto Harbor, where I took a pic eclipse, Leslie Street, you can get maybe the nude beach in Toronto Island. I doubt if there would be any heavenly bodies there, but anyway. A number of people on the Yahoo group have talked about places. There's a park, there's a reservoir on Bayview. I noticed the Humber College in the right direction. There are places around, but Toronto has lots of ravines, and maybe there's a place near your neighborhood on the east side of a ravine that looks over the ravine, and it's far enough you have a good distance. Using Google Maps, I found they are just north of Lunar or Danforth, I guess it is there. And those buildings are something like a degree or two high, and the original event will be 13 degrees up. So you'd have a good view from there. I personally like astrophotos with a piece of Earth in them. I remember a video made in New Zealand of people on a mountain looking at a supermoon rising, and it was just so magical. And I don't know if somebody could find a site where there are people standing maybe in an apartment balcony looking out. I don't know. I think make a picture that might make us astronomy picture of the day. This is going to be a wonderful event. If you live in Mississauga, the streets there are almost parallel, and it could be somebody could put up a telescope on the south side of the street, and then be able to see far enough to be able to see the event, although by 6:30 it bends around a little bit more, and that's not so good. I live in Bolton, and I don't know where I'm going to go. It depends on the amount of snow, but I have a number of places that I might end up going depending on the amount of snow on that day. And class. We're not the ones that are most concerned with it. The astrological community is very involved, and it's going to be, and presumably even for people in the rainforest, it rains all the time at this time of year. Jupiter is supposed to be fun-loving and Saturn's serious, so there's going to be a conflict. One site said it's in Aquarius, so cultural things will change, except it's in Capricorn opposite Aquarius. Another said it's going to be new beginnings because it's 0 degrees, except that ain't any astronomical 0 degrees. I don't know where they get it from. Advised to release old habits and choose a big, juicy goal. And a new word by reading that Jupiter's egoic greed and Saturn's contemplative focus need a balanced act of tempering. So if somebody could explain what that means, I cannot answer any questions. Predictions for birth signs: Virgo, prepare for a great leap. We Geminis are supposed to prioritize our pleasure. Leos are supposed to communicate, and Scorpio, find a lover you can be vulnerable with. So good luck. Other great conjunctions this century, they're all on multiples of 20 years. The closest one on the 21st of December. The one in the past that was closest was 400 years ago, and it was 5 arc minutes instead of 6, but nobody could see it because it was right close to the sun. And Shakespeare had just died at that time, and Kepler was still working on his third law. The next one that is even closer was 800 years ago, almost 800 years ago. It was much closer, very obvious, except people were watching the king sign the Magna Carta. That's a long time ago, so this is a rare event. On 6 BCE, there was a triple conjunction where there were 3 times they were together because that's just the most happened to be moving quickly compared to them. And some people think that might be an explanation for the Star of Bethlehem. But other planets have conjunctions. Regulus is a special star. Regicide is king, so it's got something to do with king. And the constellation Leo with the backwards question mark is a lion, which is the most elegant predator, I think, on land. And there was a major conjunction just here. Jupiter and Venus were this close. That's 35 arc seconds or 100th of a degree. And when I asked Ralph, he said that most people see them merging as one, but some people, young people, could see them separate. And the unfortunate thing is young people with exceptional vision usually can't afford the telescopes they need to take advantage of it, but that's life. Anyway, could you imagine people who think that the stars and the planets give us a message from gods about what's going to happen and what the meaning was? And it could be that three supposedly intelligent people with some gold incense figured it was a sign of to go to Bethlehem, and maybe it's the Star of Bethlehem. Who knows? People say, well, that's in June. This is in December, but it was 300 years ago. December 25th was picked as a birth date. Before then, Christians really didn't care about that because there was more spiritual than calendar was important. And remember, that's about the time that Newton was born. And if he had a major assistant who grew up without records, we would have no way of figuring out when his assistant was born. Anyway, lots of space missions. The are there. I doubt if you can read them, and most people can read them. And the green ones here are new ones that are forecast up to 2024. Lots of things going into space. OSIRIS-REx, it has actually just taken a sample from asteroid Bennu. Dr. Michael Daly gave a talk, and he was in charge of the laser altimeter, and he made the 3D map of the asteroid that then they used to select the place that was easiest for them to take a sample, and it looks like they did it. If you just Google OSIRIS-REx, you can actually watch the video. Highly recommended. Chang'e is the Chinese moon god, and this mission is still on the moon. They're going to bring back 2 kilograms. They're drilling 2 meters deep, that I think is the deepest ever. And this is younger soil than the Apollo astronauts saw, so it will give different news about the moon. They follow the same mission plan as Apollo. The whole mission goes to orbit around the moon. A small lander goes down, does its business. Then an even smaller vehicle, ascent module, whatever, goes back, rendezvous, and then heads home to Inner Mongolia. December 16th is the date I read, but it might be earlier. Perseverance rover is on its way. It's basically like Curiosity, but it's got bigger and better wheels because that was a problem in Curiosity. And it's got ways of detecting more biological molecules and samples it takes. But the neatest thing to me is it's bringing the Ingenuity helicopter. And if this works, it might be able, it's solar powered, so it can be completely independent from the rover. And if this works, it might be able to go and collect samples that are left behind by various missions and take them to a central spot. Like this could be quite important, but the Mars atmosphere is so thin. Observing targets. Back. We now have sunspots. And this is a mosaic that Brian Koval, who's a member of the South Simcoe Club that I'm also part of, and just amazing detail. There's supposed to be aurora tonight. If it clears up, I looked outside and there might be a patch of blue when I looked. So who knows whether we'll see aurora or not. And got this picture of an amazing prominence that is coming up and then blows down and looks source on the far side of the moon, or sorry, the sun, and it's forced upward and then it comes back. Just so beautiful. Blake always posts a list of double stars, and he mentioned that it's something that you can do when there's creeping light pollution and moonlight. And there's a whole list on the forum, and that's interesting. So we also have the stunning winter, and Orion is the only constellation that really looks like what it is supposed to be. The only one to me is the Big Dipper that isn't even a constellation, but it should be. Gemini, Auriga with its California, Taurus. There are lots of things there. And I got to point out for the Horsehead just left of the belt, the Orion Nebula, the Rosette, which is significant left belt, and the Crab Nebula, which is above the belt, and all things worthwhile seeing. A painting made by somebody for NASA, and you have your different arms, and the Orion and close to the Perseus arm, a difference between an arm and a spur. When I zoom in, you get the spur here and the Perseus arm here. And it looks like the different red patches here are the North American M42 and the Horsehead, the Rosette, and Crab is part of the Perseus arm. So clear skies and careful observing. And given that it's December, I'm going to give a Norwegian message. Thank you very much, everyone. If there are any questions, I would be happy to answer them.
Hello, Ron. Thank you very much for your presentation. Very thorough, and I know it takes an awful long time to prepare all of the information for the presentation. So thank you so much for doing this for us. Let's go to Blake and find out if we have any questions for Ron.
Hi, thanks. I've been watching the YouTube chat. Sorry, we dropped off some people at the beginning. I don't see any questions. I'm just checking now. Still don't see anything. But I have one for you, Ron. And where did I put it? I appreciate the vision chart that you provided and talking with Ralph, who's our vision expert. I'm curious, do you two think it's possible that we can see just with our eyes Jupiter and Saturn separately on the evening of the conjunction proper on December 21st? I think you said they're 6 arc minutes apart. So it sounds like on paper, we should be able to see 2 points really close together.
We can see two things that far apart, but Saturn is so much less bright than Jupiter. And it could be that the significant difference in brightness is difficult to see the two of them together. So we'll have to see, and then they're going to have to be clear skies that night so we can see it, okay?
Yeah. I'm sorry if you said it. What do you know what the magnitudes are or are going to be on the evening of the two planets? Is Jupiter around -2?
Jupiter's -2.0 and Saturn is 0.0.
Okay.
And that ends up being a factor of 11 difference in brightness.
Right.
And the Saturn is maybe half of the area of Jupiter when you count the rings. But that means that the surface brightness of Saturn is much less than the surface brightness of Jupiter. And that's going to make a significant difference in our ability to detect. And something I've wondered about trying to do, if I could get data, is to ask people to let me know if they could see two and when they could see them. Remember, I recorded the times I could see different things. And I think it might make a nice article for the journal, but I haven't decided whether I want to do it. And I would love it if Ralph would be part of it, but I haven't thought about the details. But I think that could be some interesting news that could come if enough people would give that data.
Okay, very good. I know with looking at double stars that it can be a challenge, even when the stars are mathematically in the sky, they're far enough apart. If they're very different in brightness, it can be really hard to see the two or to split them. So it's going to be interesting. I just noticed Eric's comment on the YouTube chat where he pointed out photographically it will be challenging because we've got one really bright planet and then we've got a smaller and a dimmer one. So it'll be tricky to sort of get the right exposure. Anyway, that's it. Thanks.
My guess is a number of photographers will take multiple pictures and then process Saturn and Jupiter a little differently to be able to get, to get consistent details on both. Well, thanks very much, and enjoy the rest of the meeting.
Thanks again, Ron. Thank you so much.
You're welcome.
Our next speaker is Dave Lane. He's joining us from Halifax, and as I mentioned earlier, he's a former RASC president. About the Mini-Robotic Observatory. Go ahead, Dave.
Well, thanks a lot, Paul, for inviting me to speak to the Toronto Centre. It's been a while since I've done that. I think the only time I've ever spoken to the Toronto Centre was remotely, but the last time I think I was on the phone and the audience was there in person. Anyhow, what I would like to do tonight is tell you about a project that I've been working on since March called the Mini-Robotic Observatory. And we'll just go right at it here. Just get the slides moving. So the motivation for this project was really a few things. First of all, I wanted to leverage the work that I had done for two other observatories, the Burke-Gaffney Observatory at St. Mary's University, where I'm employed as the director, and my own back window here, the Abbey Ridge Observatory. Both run the same software that I've developed over the last many years, and I thought it was an obvious. I have aperture fever. They go from small to medium to large. I seem to be going from large to medium to small. So my goal has been principally that I needed something to do. Mid-March, the university went to virtual mode, sent all its employees home. I packed my car with basically everything I could possibly think of that I might be able to keep busy and productive. So I thought, this project has been on my mind for a few years. I might have some spare time to take it on. So I did. The primary sort of motivation, in addition to needing something to do, is I wanted to make a robotic observatory that was made from inexpensive components and with such that the entire cost of everything, so the enclosure, the telescope, the camera, the filters, the control systems, the software, everything would be less than $10,000. By comparison, the university observatory cost, if you had to rebuild it from scratch, would probably be about $250,000. My backyard observatory would probably be about $30,000. So we're talking about quite a reduction in cost. I also wanted to have a development environment that I could use to write software for improving my software without potentially breaking an operational observatory. So this would be a sort of a small environment with which to play with and not worry about affecting student classes and that sort of thing. And I wanted to learn about CMOS cameras. These are the future of imaging is in CMOS, not the CCD. So I wanted to use this telescope as an opportunity to learn more about CMOS cameras. So just give a brief timeline of my work in the last, I guess, about 7 or 8 years. In December 2013, we replaced our 16-inch telescope with a 24-inch new instrumentation, new telescope, everything. And we made a promise to the owner that we would put this telescope online and make it the world's first social media controlled telescope. And we did that around mid-June at the RASC GA, which was in Halifax. We launched that facility and it's been going since. I won't go through the list of various milestones along the way, but it's been under constant development for the last 7 years. I just checked that's today, there are just short of 10,000 observations that have been requested by over 800 observers all over the world, including many Toronto Centre members, including one of our more prolific observers is actually Blake himself. I don't know how many he's observed, but I suspect probably at least 500 of the observations or so are taken by him. So again, the goals, I wanted to develop an inexpensive observatory that you could use off-the-shelf components. I wanted to be completely self-contained, sort of a scope in the box. And I wanted to be able to be small enough to fit through a 32-inch door. And the motivation there is I would like to see this telescope replicated and appear on places like school roofs. So it has to get through doorways and up elevators and things like that as a single piece. And I wanted to run the exact same software that runs at Burke Gaffney and the Ivy Ridge. So no changes, just configuration changes to adapt to the different hardware. And that forced me during the development of the software this spring to make it more flexible so that it could adapt to different kinds of hardware, different mounts, different cameras, and this sort of thing. So the software that I've developed, I really had no name for it until recently. I now call it Mission Control for lack of a name. You basically communicate it with your favorite way of communicating that most people use in their regular lives these days, whether it be Facebook Messenger or Twitter. You can even text the observatory with any phone. You can send it emails, or you can use a dedicated app that I developed for Windows, Mac, and Android. And you basically chat to the telescope and it replies back. So when you request an observation, you first of all, you request to get authorized as an observer, and you're given certain privileges and a priority. And then you make requests and get validated and queued and then observed sometime later. And then as the telescope, oh, sure, you can also, while you're waiting for your observation to be taken, you can query the observatory's database, you can edit your observations, you can delete observations, you can check the observatory status, learn lots of things about the observatory. And then when it actually runs, each clear night, the telescope opens. The observations are taken in a sequence that is based on an algorithm that prioritizes observations, for example, for students in the case of the Burke Gaffney, or in an order that's efficient, or certain types of observations get more priority over others and this sort of thing. So then it communicates with the observers while it's taking the observation messages, either through Twitter or whatever medium they're communicating with. And then it sends them live images on the public internet through Twitter and through private messages to their however they communicate with. And then in the morning, it does a better job of processing the images and makes the raw data available so that you could do post-processing after the fact. And images appear publicly on our website. So I won't go into details here. I'll give you some examples later. Things like an example, first one here, request equals M42, and that would cause the Orion Nebula to be placed in the telescope's queue for observation. It's as simple as that. There are lots and lots of commands. There's probably about 50 commands for doing different things, all on the website, and people do seem to read the website, and they do seem to figure it out. User training necessary. People just don't seem to be able to figure it out. And now, there's the app version. You can even use simplified commands like take a picture or what's your status or tell me the weather forecast, that kind of thing. You can just type plain text commands and it will respond. This is sort of a typical I guess, chat between the telescope and an observer. This is for the Burke Gaffney, so I've asked the weather and then asked it to look up an object to see if it's observable or not. I've made a request for M87, and then for NGC, you can specify filters, exposures, multiple filters. You can do time exposures, time series, I should say. You can specify various parameters about when and how an observation will take place. For example, an object, when the moon's not up, this kind of thing, and away it goes. And just for the moderator, my time clock has just stopped, so you'll have to give me some warning here, my time when I get close, because my clock no longer tells me that. So we started modestly back, I should say because everything has been me this spring, because I've been working alone here. Back in March and April, started just by assembling the components on the deck behind the house without any enclosure, just on the tripod. Eventually, I built a stand that would eventually be used inside the enclosure. Had a few setbacks along the way. We used this garden cart to get the observatory from the back on the basement to the deck, and we had an accident one day. Luckily, we didn't actually break anything except for this wood here on the mount. Luckily, the telescope did not get smashed. Early on, we were using it. In fact, team members across the country using it. I would set it up on the deck on a night that would not necessarily become rainy, and let it run all night, just sitting on this rolling cart. Then I built an enclosure made of wood. This was made entirely with scrap. Couldn't make many trips with hardware during COVID, so I basically used materials that were just in the basement from left over from other projects, and eventually I ended up with this enclosure, which I'm pretty happy with. The final product here is taken on my deck a few days ago. Weatherproof, pretty much anyway. We'll find out over how weatherproof it actually is. And here's an open configuration. Got a video I'd like to play you, so we can cue the video.
Okay, let's start by opening the roof. We'll use the Android app for that. Open Sesame. Takes a few seconds for it to check a few things before it starts to open.
I am opening the roof.
Okay, while it's opening, I'll just mention a few things. It sits on any flat surface. You just shim it to get it level. On the side, on the east side, there's an access panel that allows you to get inside in the event that the computer won't open the roof for you when you request it. There's a cloud sensor which is separate, and it's oriented with the long direction in the north-south, and the shorter is east-west. So on my right here is the western direction, east is this way. The opening and closing is done by 4 linear actuators, and these have auto stops in them, so they run as far as they can and then they stop. And when closing, there's magnetic switches here that are used to detect that the roof is in the closed position. Let's move the telescope. Go to Ring Nebula now.
I am moving the telescope to Ring Nebula at azimuth 95 degrees and altitude 56 degrees.
Okay, inside we'll find the telescope is a 4-inch Genesis refractor. I've had that telescope for nearly 30 years. And on the back end there's a CMOS camera from ZWO and an 8-position filter wheel that includes the regular red, green, blue luminance and the 3 narrowband filters. The mount is a Celestron Advanced VX, which is a pretty good mount at a really good price. So it fit well with this project. Other features you will find in here, let's move around to the other side. There is electric focus, Pegasus Astro focus cube, and over on this side is a relay controller used for turning things off and on, running the dew heater, and a USB hub which can be controlled such you can individually turn on and off USB devices, which is an excellent feature when you're running remote and you need to reset something without rebooting the software. Under here is the computer. It's a sort of a brick style computer, self-contained, includes everything that the observatory needs: a website, database, data storage, image processing, and a power supply here on the right, which essentially is just 12 volts. So this system could be run on 12 volts or 110 as I have it presently configured. And last but not least, this little device here is a ultrasonic sensor which detects the presence of the telescope above it. And that's just a safety feature to make sure the telescope is in its parked position before it tries to close the roof. Otherwise, the scope would not fit, and that would not be good. So we'll just end this brief video, and we'll close the roof. Close sesame! And as part of that process, it recognizes that the telescope is not parked, so needs to be
I am closing the roof.
parked first, and then closed. So I'll just walk away as it closes the roof.
Okay, so here's just a quick snapshot of some of its tech through this, but in particular, and that's the field of view. With a short focus refractor like the Genesis, you get a beautiful field of view of about 2 by 1.5 degrees over here, and reasonable image scale for deep sky imaging about 3 seconds. So you can and higher resolution. You can also zoom in quite close to small objects as well. So it's for really big objects, such as fitting the M31, for example, in one frame, or getting reasonable resolution with a globular cluster such as M13. So let's do a quick demo here. Drag over the app just to show you a little bit of how it's operated using the app, but the messages you send from the app are the same as what you would send through Twitter or Facebook or text or whatever. So one example might be I want to find out what the status of the observatory is. And so as this is not operating at the moment, I have it disabled. I want to find out what the forecast is for tonight. Forecast. Grabs a weather forecast off Environment Canada, not good. Want to request an object. It's literally like request object equals, I don't know, M31. I want an exposure of 10 minutes. Done. Now that's in the queue. If I go over to the website and look at my requested observations, there's my object. So it tells me the filter that it chose, the parameters of the observations. It will, if you don't specify things, it will end up picking appropriate values or based on the object type. So longer exposures, for example, clusters, it'll pick appropriate exposure for the moon and things like that. You can, from the app, you can also go bring up your completed observations. So I want to see what I took here. Well, actually, I've been down for a few months. Here's one I took back in the summer. So this is a calculation of the Veil, part of the Veil Nebula. One of the things you can do, I won't go into the details of it, but that is unique to this observatory system is the ability to actually do image processing through the social media interface. So you can do things like image combines, color combines, filtering, cropping, mirror flipping, all kinds of things from using a process command. So for example, if I go back to the website and look at the processing that was done by another observer, this is an observer in Italy, and he's been using it. Here's M17, so that's a silicon Gen 3 8, and something happened. I think what happened is there we go. Through the narrowband filters and separately, and then created this image through the processing feature. So I'll stop the demo because I don't have time to just continue along. One of the things that I did develop this spring and over the summer was the ability to actually do live observer interface, and that was necessary because the university went full virtual this fall, and I wanted to provide an experience where students could log in through Zoom, and this example shows where we had 3 students and a TA, and this was me taking a picture of the screen, doing live observing through a web browser interface in such a way that you could use this interface for anyone, give it to anyone, let them use it, and they can't break the telescope because their ability to control things is constrained by the options in the software. So this is a feature I'm really excited about, and I hope to use it soon for virtual star parties with all those, particularly the Burt-Gaffney. How does it work? Well, it's complicated. This is sort of a block diagram of all the various pieces that make up the observatory. The blue box things are software, hardware that I've developed. The non-regular black boxes are things off the shelf, such as the cameras, the focus cube, Maxim DL software, cloud sensor, and so on. The software is about 100,000 lines of code that's just directly related to running the observatory. Yeah, I won't explaining how it works and going over that in detail is a completely different talk. But we're getting to the end here, so let's hope that here's your open invitation to use this telescope yourself or the Burt-Gaffney Observatory as well. You can just send a tweet to the telescope. Its Twitter handle is obsmini, and just use this format, authorize with the hashtag, hi, tell me who you are, and you're from the Toronto Centre, and we will authorize you, and then you're welcome to use it. The information on how that all works is on the website. To become authorized, you can request objects such as the moon and 13, some examples that are observable this time of year. You can observatory weather, you can get status, request observations, query your requests, and so on. So that's about it.
Dave, thank you so much. That is a truly, truly impressive. Thank you for sharing it with us and giving us all the opportunity to try it out and get some images. Thanks again.
Yeah, it was a fun project work. Trouble over the last few months, that's for sure.
Fantastic. You might be a long time ago, and I went through my log, and sure enough, I found your presentation in May of 2004. You spoke to us about the construction of the your personal one, right?
That's right. Yeah, it was built, so that wasn't 2003. So it would have been the next year. Yeah.
Right. So we've gone way too long. 16 years. Not hearing from you. I'll remember that. All right. Let's go to Blake. Any questions for Dave?
A couple of questions. A couple of people have been wondering how you mean voice recognition. Are you letting what I think you have an Android phone, were you letting the Android voice recognition, or are you doing that all yourself?
On the Android platform, exposes their voice recognition technology. So you can basically just, as a programmer, you can call that box to pop up that you would use with any application. And what happens is it sends your voice off to wherever, and it gives you back the text. And then that text is then processed by my software to remove extraneous stuff and look for keywords. It's not what I would say intelligent in any way. It looks for common words. You do have to follow the format that it is expecting.
And related to, is there on an iOS, on an iPhone, is there the equivalent capability? Can you speak a command?
There actually is. It turns out that Apple, given that they control the world, they have decided not to expose that voice interface or a Siri-style voice interface unless you are Apple and use it within their application. So that feature is not available for iOS. I should have mentioned that for a while I did have an iOS, iPhone, and iPad app available as well. Apple makes software developers crazy, and they changed enough things that my app will no longer work unless I buy a new Mac to develop. So I have to go spend a few $1,000s to buy a new Mac to be able to continue the development of the iOS, unfortunately.
Yeah, if you start drinking the Kool-Aid.
Yeah, my
Okay.
Mac is right behind me. It's,
I used to have more Macs than PCs, but I don't anymore. I have a question for you. The Burt Gaffney Observatory, it's really sort of straightforward and to a degree predictable to use. That is to say, if you see using the Halifax Clear Sky Chart, it's easy to see, oh, clear weather's coming in, you know, and know what the moon phase is, and you can queue up some jobs if you haven't already. What's the best way for someone interested in using Mini-Ralph, using the MRO, to know that it will be operating based on weather?
Yeah, from now on, it's more likely to run than not. It was down a fair bit over the summer, just largely because I was distracted with other projects, and earlier this fall I had students to deal with. I also had some unreliability to do with the roof, which I've since resolved in the software. So I now trust that if precipitation comes along, it will actually close and it won't rain or snow on the telescope. So it's more reliable now. So I'm less concerned about letting it run regardless of the weather. But the best way to sort of keep up on all of the observatories, and that's the BGO, my own backyard observatory, welcome to use as well. That's an RASC member. The Facebook group that is, I forget exactly what it's called. It's like robotic imaging at ARO, BGO, MRO, and that's a discussion. And I tend to put announcements there about any technical issues that are coming up. There.
And you also have specific status pages on the web as well, I recall.
That's right, yeah. And now that I'm sort of making this, I want this thing to be more online now that the students are gone, and I'll have less on my plate this coming winter. My is to use it more than not and have it running as often as possible. And now that I'm effectively home and locked in this house pretty much just like everyone else is in COVID, I'm not going anywhere, so it's likely to run more than given here in Halifax. I will say it is a bit time consuming to be the slave to 3 robotic telescopes, particularly all same, and they all sound the same, and they interesting when you have them all running in one. Starts at say 5:35. ARO starts at 5:36 because it's 1 minute of Earth rotation later. And the ARO is literally a few feet away, so they theoretically would all start within 1 minute and be up and running at the same time. So when things tend to go wrong or need tending, they all need my attention all at the same time. But the BGO largely doesn't need any effort, and the others less so as I resolve issues, which hopefully things are stable now. But I do intend to use the Mini-Robotic as a test bed for new software. So it will probably always be running a later version of the software that may be more buggy than what's running at the BGO, for example.
I think that's a little bit of be careful what you wish for. So Leo2 CAF asked, can the MRO single there's looks like there's a the standard hand controller there. Do the various in the MRO box, are they going to stand up to really cold conditions?
Yeah, I don't. The computer has a solid state drive, so I'm less worried about the hard drive, and it will be left on all the time, so it should be. any problems, I'll just put a bit of insulation on it. I had arrow next to it, and the VGO. The arrow sits outside as well. I have a heated box for the computer for that, but the instrumentation, the telescope, I guess time will tell to see how well the mount works in the winter. You know, these California design, they have issues sometimes up here in Canada, but really the here, so it's, you know, minus 29 is pretty rare. Yeah. Well, time will tell. The roof I'm not too worried about. I mean, I can see it in the daytime. I can see it at my window to my right here. So I expect that, you know, it'll be much easier to get the snow off of it than the arrow next to it, which I have to use a ladder for. So, you know, ice. And the other thing I should mention is that the roof design is set up so that if the roof has too much force to open it, it detects that and you know, burn the motors out or something like that. It intentionally detects over current, so it will not open rather than destroy itself.
Okay, thank you. Ward asked about the app. He referred to Google Play, and he tried searching for it. So is it visible and exposed on Google Play? I just fired up mine, and it's called Communicator, right?
Yes, and my guess is that I have tried to find it through the Google Play search, and it's really hard to find. I don't know why. It's probably because there's so few downloads that it doesn't percolate far enough up. If you go to the Burke-Gaffney Observatory Robotic Telescope page, which is observatory.smu.ca, and look for the robotic telescope menu and look down the list, there's a communicator menu item, and the direct link to the Android app is there in the Play Store.
Great. I included the link to the MRO in the YouTube chat early on, so following that thread, people should be able to find that. Hal is online, and he asked, in gaining experience with a CMOS camera, any lessons learned there yet regarding imaging with the new types of cameras versus CCD?
Yeah, it's too early to tell. Encouraged. The big issue with CMOS, expensive ones, is that the analog to digital converter is typically that means you only get a range of 0 to 4095 counts versus a normal CCD camera, which would be 0 to counts. So you have to be careful with the scale or with the overexposure, because you don't have much dynamic range, would be, I guess, the term I'm referring to. The other problem, the software allows you to change the gain, but it does not allow a programmer to change the gain. So you have to do it manually at the moment. So if you wanted to really to look at faint stuff versus bright stuff, you're really stuck at the moment. And I've got some ideas on how to make that adjustable programmatically, but at the moment you have that a fixed gain and just live with it until you go and manually change it, and that's a limitation. The other big problem with CCD is you can't bin them on the chip. So if you want to bin from a high resolution to a low resolution to match your camera, the binning happens mathematically after the fact. So it's not done by moving, it happens in a CCD camera. So there's our limitations in doing that, and how much that affects the result, time will tell. Someday I may try some objects. I have a small CCD camera that shoot the same thing, apples and oranges, just to see how they compare, and that might be a good winter project to do. But right now, in the next sort of, when I get a minute, I'm going to crank the gain up to see how that affects it. The big question is, are we doing science or are we doing pretty picture imaging? At the moment, it's set up more for science than, except the filters aren't the right ones. But as far as the gain, if I wanted to do pretty, probably would crank the gain up more, just because this camera is very, very, very low noise. I hope that's the question.
Okay, I think that's all for questions. I just want to say thank you very much. It was your authorizing me to use the BO, letting me do an imaging run, a special case one with the ARO. I was able to image all of the RASC finest NGCs but one.
Yeah.
So that was that.
Some trees since we've last spoke. You want to try that other one, it may now be possible.
Right.
One thing I've learned is cutting trees down involves making sure your spouse is occupied while the operation is happening.
Right. Okay. Thanks again.
Thanks for the invitation.
All right. Thanks again, Dave. Let's move on to our next speaker. Jerry Vila was about the life and discoveries of Galileo. Go ahead, Jerry.
Yes, I'm here. I will start the slides then. Yes, good evening, and thank you for the opportunity to talk about Galileo Galilei, inventor, physicist, and astronomer. He was born in Pisa, Italy in 1564. 20 years after the publication of Copernicus on the revolutions. I hope you can see me as well, because I'm just looking at the slides. As a student, Galileo was interested in priesthood, but was pressured by his study medicine. In 1583, 19-year-old Galileo entered the University of Pisa, but he never seemed to have taken medical studies seriously. Instead, he attended courses in mathematics, physics, and natural philosophy. Due to financial difficulties, Galileo left the University of Pisa in 1505 without completing his medical degree. This is the picture of the younger Galileo Galilei. After leaving the university, Galileo continued to study mathematics and supported himself with minor teaching positions. During this time, he also began 2-decade study on objects in motion and published The Little Balance, where he described the hydrostatic principle. Now, there are some popular distortions about Galileo, and maybe I can address them here now. Galileo did not invent telescope, but he understood it once he saw an example of it, and he improved it and used it well for celestial observations. While the Galileo was prosecuted by Roman Catholic Church, he recanted to save himself. Didn't want to end up as Giordano Bruno. Galileo indeed used many experiments, and I will touch on some of them as we go through this PowerPoint presentation. But the most important were his thought experiments. Since he lived in a time where senses were aided by rudimentary apparatus, he had no timepiece more accurate than his pulse. Galileo found that reason and bold speculation had to step in rather often to bridge the empirical data. There is one of these thought experiments. If a ball is cut in half, each half should soar according to Aristotle. But reasoned Galileo, what happens if the two halves are connected by a thread or a stick? The Aristotle physics of falling body cannot be correct. This was, by the way, demonstrated by the Apollo astronaut of the airless moon using a feather. Here Galileo is dropping objects from the Leaning Tower of Pisa, that items of the unequal weight fall at the same rate of acceleration. Well, that's kind of a popular image. Well, the experiment would not work very well owing to the air resistance. The heavier, denser object would have hit the ground first. Although a cannonball and a musket ball would fall at the same speed. Here is in the Leaning Tower of Pisa. I am trying to hold on to it. It started to lean as early as it was being built. And this is, of course, a site. I just would like to point out that in the city of Pisa, there are many beautiful buildings rather than this one right here. You can see right in front of you, that's the baptistry. Behind it in the middle, and towards the edge is the Tower of Pisa, which is really a bell tower for the cathedral. 1589, Galileo found a new position at University of Padua, which is west of Venice, northern Italy, teaching geometry, mechanics, and astronomy. The appointment was fortunate for him, since his father died in 1591, leaving Galileo entrusted with the care of his younger brother. During his 18-year tenure at Padua, he gave entertaining lectures and attracted large crowds of followers, further increasing his fame and his sense of mission. Now, the different subjects that Galileo studied, he experimented, of course. He studied speed and velocity, gravity, free fall, the principle of relativity, inertia, projectile motion. He also worked in applied science and technology, describing the properties of pendulums and hydrostatic balances, inventing the thermoscope and various military, and using his telescope for observations of celestial objects. Now, this is a modern version of thermoscope that you can purchase in a gift shops. And on your right-hand side is a reconstruction of Galileo telescope. As you can see, it's a reflector. Reflector hasn't been invented yet. In 1609, Galileo demonstrated his first telescope to Venetian lawmakers, including the Doge of Venice. Venice has no walls. It is protected by water, and there are a number of islands. And the Venetians needed it to see if their cargo ships or enemy ships were approaching. That was their defense, their trade. At the time, Galileo studied mechanics and astronomy at the University of Padua, which was part of the Venetian Republic. If you take a car, it's about an hour drive, or maybe 1.5 hours. And because here is the famous picture of Venice, Laguna. There are several islands. On your right, you can see the Doge's Palace. And here is the St. Mark's bell tower in Venice. And many of the observations were done from the top of the bell tower right here. There is another picture I took. There is, at the background is the St. Mark's Basilica. And here at the middle is again a bell tower of Venice. Here the Galileo is demonstrating his to Doge again in Venice 1609. This painting seems to demonstrate that it was watching at night, watching the skies. A year after the demonstration of his telescope, Galileo published Starry Messenger. That would be in 1610. The publication suited the heliocentric system, which described findings made with his improved telescope. Here, Venus has phases like our moon. He also observed Jupiter for moons, Saturn rings, and innumerable stars. He also did a painting based on the telescopic details of moon that's shown on this slide in the upper end. And at the lower end, you can see the 4 major satellites of Jupiter that sort of line up. And of course, that led to another discovery that not everything orbits around the Earth, which we know. The upper picture here are the rings of Saturn as seen by Galileo. It looks like, for what he could tell from his telescope at the beginning of 17th century, is that the Saturn had ears. And from the movement of sunspots, the part of the slide, he concluded the sun was spinning and the Earth was in an orbit around the sun. If you study those spots for a prolonged period of time, you can see how they are shifting, and that's caused by the orbit of Earth around the sun. Well, Galileo's support for heliocentric system met with opposition from Catholic Church and from some astronomers. I guess that doesn't include us, right? The matter was investigated by the Roman Inquisition in 1615. And that would be the painting on your right-hand side. Well, the Inquisition concluded that heliocentric or Copernicus system was foolish and absurd in philosophy and formally heretical, since it contradicts the Holy Scripture. The painting, the Galileo here, and the Jesuit. Back in 17th century, religion was a center of the everyday life. And this changed since then somewhat. There is another illustration of the phases of Venus to prove that the Venus lies closer to the Sun than Earth. Galileo recognized that his observations supported Nicolaus Copernicus' theory that the planets revolve around the Sun. His advocacy of the theory culminated in his last publication, Dialogue concerning the two chief systems, Ptolemaic and Copernicus. And that was in 1632. Well, Galileo dialogue concerning the two chief world system was published in 1632, as I said, and it appeared to attack Pope Urban VIII. This time, he alienated both the Pope and the Jesuits, that up to a point were somewhat on his side. Well, he was tried by the Inquisition again in 1633. Was found guilty and vehemently suspect of heresy. He was forced to recant and spent the rest of his life under house arrest. That house arrest wasn't so difficult necessarily. He had a servant, he lived in a nice house. And there Galileo died in 1642 at the age of 77. The Renaissance was in full swing, of course, but the Middle Ages still ruled. Here is Galileo facing the Roman Inquisition at that second trial at 1633. And that's one of the painting here. And I have a note here. In 1987, John Paul II, he was known also as a Polish Pope, canonized new saints and also stated the prosecution of Galileo was not just. Well, I guess we figured it out by then. This time the new saints were from the Central Europe. They were not necessarily Italians or French. And many people from there, from Central Europe, visited Rome for the first time. And that was a big demonstration. By 1989, 2 years after, the Commune of Bulgaria and the Soviet Union 2 years later, in 1991. So it tells you something. It was not necessarily that all the people suddenly started to believe in the Roman Catholic faith, but I guess they just didn't want to believe and being told what to do anymore. Now I will switch to Galileo's private. In 1600, Galileo met Marina Gamba, a Venetian woman who bore him 3 children out of wedlock, daughters Virginia and Livia and son Vincenzo. He never married Marina, possibly due to the financial worries, and yet he feared his illegitimate children would threaten his social standing. Galileo was concerned that his daughters would not marry well and had them enter a convent in 1616. His older daughter, Virginia, there's a picture here, changed her name to Maria Celeste. She remained in contact with him through letters until her death. And his son, Bears, was eventually legitimized and he became a successful musician. Now I will go to Maria Celeste here. And why? Because the letter she sent to Galileo were saved. Maria Celeste was a very devoted daughter, and her letter from the convent survived. The letters are collected in the book, Galileo's Daughter. I would highly recommend this publication, this book. I read it. And it opens a curtain on a life in the 17th century. So if you have a chance, go to the library to pick it up. Unfortunately, Galileo's letters to her daughter, to Maria Celeste, were destroyed in the convent when Maria Celeste died. Actually, reading through these letters, I have a personal opinion that her premature death was caused by starvation. Galileo Galilei wrote, "The great book of nature is written in mathematical language." In 1648, under the house arrest, and throughout observing the stars, scientific experiments. He is buried in Cathedral of Santa Maria de Fiore in Florence. And this is the picture of the famous cathedral. This one is very famous and popular with tourists. And again, I would like to mention there are many other churches in Florence and museums as well. Is or a monument on a tomb of Galileo Galilei in the Basilica on Croce in Florence. Galileo was originally buried in the Noviet Chapel that is connected to the Basilica. Nearly 100 years later, however, his admirers were able to exert enough influence and spend enough money for the elaborate monument that would be put right in the Basilica. That's the one here on the right. His body was exhumed and moved there in 1737. One interesting aspect of the tomb is its location. It is directly across from the tomb of Michelangelo, who died within a few days of Galileo's birth. Some say that spot was chosen because there was a popular belief that Michelangelo's spirit left his body and went to Galileo. Another interesting aspect of the tomb is that there are two bodies inside. One is the body of Galileo, the other is the body of his daughter, Sister Maria Celeste, who was writing him all these letters. When Galileo was exhumed to be moved, the body that was so was of a woman. Galileo's body was found underneath the woman's body. It turns out that his pupil, one of his pupils, had secretly buried Galileo's daughter there in the first grave as a posthumous gift to him. As a result, both bodies now rest in the tomb. One final note, when Galileo's body was moved, his admirers took 3 fingers, a tooth and a vertebrae as a keepsake or relics, and they are on displayed in Padua and Florence. Well, I guess we would find the relics, religious or otherwise, rather odd in our century, but these religious relics were important. In Middle Ages, a church would not be built unless they would have a relic to put in it. So the religious relics were important at the time. This presentation I prepare is a small tribute to a man, Galileo Galilei, who changed our world by introducing science to our lives. We should remember him on some occasions. Thank you very much for your attention. And if you allow me, or if you can now, we can watch Galileo's experiment video, please. Thank you.
Well, in my left hand, I have a feather, and in my right hand, a hammer. And well, I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects and gravity fields. And we thought where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon, and I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? And that proves that Mr. Galileo was correct in his findings.
Superb, Dave.
Well, I always say there's nothing like a little science on the moon.
All right. Thank you very much, Jerry, for sharing this with us. And let's go to questions for Jerry.
Yeah, we have a couple of questions. There were a few people who were actually commenting on Galileo's vision. He went looking at the sun and sunspots, but it's been clarified that he used different types of telescopes and he used the camera obscura.
Right.
A question that was raised, though, Jerry, by Cicely, did the younger brother of Galileo make any significant contributions to any field of scientific study?
Well, thank you for the question, but maybe it's my answer. I do not know. I haven't researched that.
Okay, no worries. And I have a question for you, and again, this might be tricky. I've been really curious if Galileo, with his new instruments, might have been able to observe the 1623, I'm not sure if I've got the year right, but the great conjunction of Jupiter and Saturn. Now we know that those two planets were much closer to the sun, so maybe could not have been seen in the bright sky or in the glare of the sun, but probably leading up to the conjunction proper or after it, there would have been opportunities to observe it. So my question to you, Jerry, is do you know if Galileo's his notebooks or his observations are available to the public? Could one sort of search them and review them?
There is a lot to find on the internet these days. I haven't really came across that conjunction, but there was a great observation in his days about and supernova at that time. And those were rather revealing, and they stir up lots of enthusiasm about it. But I am not sure, I haven't come across the conjunction of those planets.
Yeah, it doesn't seem like there was much observation, and certainly there weren't a lot of telescopes around at that time. So
yeah, the telescopy, sorry. The telescopy was in its infancy, and the number of limited telescopes, and they would be only available at the time in Europe, for all we know. Kepler asked Galileo if he can send him a telescope, and Galileo unfortunately did not reply to his letter. Kepler would be able to do fantastic observations because he had a theory very well worked out, and he had a telescope because one of the nobles from Germany visited in Prague, and he lended the telescope to Kepler. Kepler was very impressed with the telescope. He immediately understood the principle of the optics, but he couldn't find good optical objectives to put the telescope together. And he wrote a letter to Galileo. And what I know, Galileo didn't really answer positively to his request. He says it's too much work, and he was making the telescope for the nobles who would pay him well, so he didn't send the telescope to Kepler. I don't know whether that answers your questions, but that's what I came across.
Okay, thanks, Jerry, for all the great info. Appreciate the talk.
Thank you.
Thanks, Jerry. Once again, I know it takes time to create these presentations for us. So that concludes the speakers lineup for this evening. Next, we'll go to Tom Luton for the announcements. Are we ready to go with Tom? There we go. Perfect.
Evening, everybody. So yeah, if you missed our meeting last week, I've replaced Ralph as president. So I've moved from occasionally giving the start of the talks to now I'll be giving the ends of the talks. So let's get started here. Oops. All right, so as Paul previously mentioned, we have two types of meetings here. We have our recreational astronomy nights and we have our speaker nights. Now, we have had a few glitches this evening, but please stick around for our YouTube chats on a regular basis. And if you're able to attend live, please say hi, add some questions for the presenters in the chat. If you're a new member, introduce yourself. And if you're from a faraway place, let us know where you're from. So our next recreational astronomy night is on the 6th of January. And it's going to be Chris Vaughn with Sky this month. Brian Zarnick will be discussing football and astronomy, the making of the giant Magellan telescope mirrors. And Tom Othos will be giving us an update on making a thin meniscus mirror telescope. If you'd like to give a lecture, give a note to Paul Markov and let him know. So we don't yet have our next speaker, which is going to be on January 20th. Remember that with the holidays coming up, we don't have a speaker night in December. So we'll let you know as soon as we get our new speaker. So our educational and public outreach activities that the Toronto Centre is famous for are on hold because of COVID. But we are planning virtual star parties and EPO talks with the Ontario Science Centre at Millennium Square, the David Dunlop Observatory, the St. Clair O'Connor Community Centre, the Dunlop Institute with Brownies, Cubs, Scouts, schools, and we will be going through our new Observers to Visual Astronomy course online. Contact public education at rasto.ca for more details, and we'll keep you apprised. So, unfortunately, because of COVID, all of our observing sessions are suspended until further notice. Bayview Village Park, the Longstu Conservation Area, and the Ontario Science Centre, all of our night observing sessions are offline for the time being. The Carr Astronomical Observatory, our own club observatory up in the Blue Mountains, is closed until further notice. The only thing going on up there is occasional maintenance activities. But we still need volunteers. So if you're a Toronto Centre member and you're interested in helping and you've got some free time, please let us know. We'd love to have you, and we can find something for you to do. No problem at all, and no worries about your skill levels, or all we need is enthusiasm. We're really looking for two major job postings at the moment. The first off is chief editor of our newsletter Scope. This is a bi-monthly publication that reaches every Toronto Centre member either electronically or through the mail. Yes, we still do it the old-fashioned way. So if you like to write and to edit, if you have a bit of a flair for journalism and for writing, please drop us a line at volunteer@raskto.ca. If you're looking for something a little more casual, we are looking for a new light pollution abatement committee head. If you care about the environment and if you like advocacy, please, again, let us know. The best thing about this job is the job title. You get to call yourself